This is a review for quiz 4, which covers chapter 4. We'll go ahead and start with graphing an exponential function. So we need to plot at least 5 points and graph the asymptote. I'm going to go ahead and graph the asymptote first. Since my function was not moved up or down, my asymptote is going to be in its normal spot, which is the x-axis. So y equals 0 would be the equation of that asymptote. Now that the asymptote is done, we can go ahead and draw the actual function. If you don't remember what the function looks like, you'll have to make a table of x, y values. Generally, we put in -2, -1, 0, 1, and 2 as our points for x, and then plug them into the y and figure out what the y coordinate is. So this is 2 to the -2 power, which is 1 over 4. This is 2 to the -1 power, which is 1/2. 2 to the 0 power, 1, 2 to the first power, 2, and 2 to the second power, which is 4. We'll go ahead and plot these points and then connect the dots. Make sure that your graph does not cross the horizontal asymptote. Let's try it again with a different base. Once again, the function is not moved up or down, so the horizontal asymptote is still going to be at the x-axis. Table of x, y coordinates if you don't know what the function looks like. If you do, you can just graph it without doing the table. So 1/2 to the -2 power is 4. 1/2 to the -1 power, that's 2. 1/2 to the 0 power is 1. 1/2 to the first power is 1/2. And 1/2 to the second power is 1 over 4. Plot the points and connect the dots with a smooth curve. As always, do not cross the horizontal asymptote. Number 2, we're solving these basic logarithmic equations. The easiest way to do so is to turn them into an exponential. So the first one, this would be x to the 6th power equals 64. And then to get rid of the 6th power, we have to put both sides to the power 1 over 6. 6 times 1 over 6 is 1, so this is just x, and 64 to the 1/6 power is 2. Same thing right here, turn it into the exponential. This is 6 to the -2 power equals x, so 1 over 6 squared would be your x, and then 1 over 36 is x. This is fully simplified. Number 3, radioactive substance has a half-life of 25 years. The amount A in grams of the sample of the substance remaining after t years is given by the following exponential function. Find the amount of the sample remaining after 12 years. We're going to round to the nearest tenth. So all you have to do here is plug in 10 for t. So this is 623, 1 over 2, and then 10 instead of t over 25. Put it into your calculator, and you should get 446.7 grams remaining. Number 4, a city has a population of 36,000 people. Suppose that each year the population grows by 4.3%. What will the population be after 5 years? Okay, on this one, we're using this formula. P and then b to the t. Sometimes it's written like this, p equals p naught b to the t. We have p naught, which is the initial population at 36,000. We have r, not b, but r at 4.3%, so 0.043 in decimal form. And then we have t at 5. Now we need to figure out what b is. The population is growing, so b would be 1 plus r. So that's 1 plus 0.043, 1.043. Now I'll go ahead and put everything into the actual formula. Population equals 3,600 times 1.043 to the 5th power. And that will be 44,435 people. We did round to the nearest whole person. Number 5, a laptop computer is purchased for $1,750. After each year, the resale value decreases by 23%. What will the resale value be after 4 years? A similar problem as before. We have P naught, or the initial price, at 1750. Then we have rate at which the price is decreasing is 23% in a decimal format, 0.23. So since the price is decreasing, B would be 1 minus R. So 1 minus 0.23. That's 0.77. Now we'll go ahead and plug it into the formula. So P equals 1750 times 0.77 to the 4th power. T equals 4. I didn't put that down. Put that into a calculator, and you'll get $615.18. Okay, we're given the graph of 1/3 to the x power. We need to use the grid next to it to graph the transformed function. The transformed function is x minus 2 plus 2. So we are moving or shifting 2 to the right and 2 up. Since the function has a horizontal asymptote at the x-axis, the vertical shift will affect that horizontal asymptote. So the asymptote is going to go up 2 also. So it'll be right here. Now we'll go ahead and plot all the rest of the points. Let's see, this point, maybe this point, and maybe this point. So 2 to the right and 2 up. Here and here, it's at 2, 3, so that's right here. Then this point, 2 to the right and 2 up, it's at 1 and 5. That's right here. And this point, 2 to the right and 2 up, well, that's going to be off the screen, so I guess we're not going to be drawing that one. We'll go ahead and connect the dots here. Make sure you're not crossing the horizontal asymptote. The graph of the exponential is shown below. We need to figure out domain, range, and the equation of the asymptote. Domains of the exponential functions are not restricted, so negative infinity to infinity. The range for the first function, which lies completely below its horizontal asymptote, will start at negative infinity, and it will go up to the horizontal asymptote, which is 4. We do not include the asymptote as the graph does not touch it. The asymptote is going to be at y equals 4. Second graph, domain is still not restricted. The range, this time the asymptote lies above its horizontal asymptote. So the graph is above the asymptote, which means it starts at the asymptote at -3 and goes all the way to infinity. The asymptote this time is at y equals -3. The sample of 357 milligrams of radioactive substance was present at the start of the study. Since then, the sample was decayed by 5.3% each day. Let T be the number of days since the start of the study. Let M be the mass of the sample in milligrams. Write the exponential function showing the relationship between M and T. Now, the typical exponential functions look like this. P equals P naught b to the t. Now, instead of p, we have m. T is still our variable, but instead of p, we have m. The initial amount is 357 milligrams, and then it's decaying by 5.3% per day. So 1 minus 0.053. We cannot work with percentages. We have to turn them into a decimal minus because it's decaying to the power t. So this is a perfectly good answer. But if we wanted to show it in a simplified form, we can do so by just rewriting the thing inside the parentheses. So this is an or, you don't have to do both. M equals 357, and then just do the calculations inside the parentheses, 0.947 to the power t. Either answer is correct. A study is done of a number of bacteria cells in a petri dish. Suppose that the population after T hours is given by the following function. Find the initial population size. Well, that is the size at T equals 0. And if you plug in 0 for T, 1.052 to the 0 power will be 1. So the initial population size is just 856. Does the function represent growth or decay? Well, b is 1.052. It's bigger than 0, so it is a growth problem. By what percent does the initial population size change each hour? Well, since it is a growth problem, then b would be 1 plus r. We need to find the rate, the percent shows that it is the rate that we're looking for. So let's go ahead and rearrange this equation for rate. R equals B minus 1. So that would be 1.052 minus 1. So that's 0.052, and then turn it into a percent by multiplying that number by 100. That's 5.2%. So we just multiplied by 100 here. So the population is growing by 5.2%. Number 8, we're going to be solving these equations for x using the common basis technique. So 10 to the power 3 minus 2x equals 100 to the power 6x. 100 is a power of 10, so this is 10 to the 3 minus 2x equals 10 to the second, that's 100, but it was already to the power 6x. So we'll go ahead and put that down also. Now that the two bases are the same, we can drop the bases and just equate the exponents. And then it's a simple linear equation that we can solve. X, let's put all the x's on one side. So add 2x to both sides. And then divide by the number in front of the x. This is 3 over 14. Part B, we have 16 and 8. They're both powers of 2. 16 is 2 to the 4th power, and then I already have 2x as an exponent. 8 is 2 to the 3rd power, and I also have 3x plus 4 in the exponent form. Now that the bases are the same, we can drop the bases and just equate the exponents. And now again, it's just a linear equation. So let's go ahead and open up the parentheses. 8x equals 9x plus 12. Put all the x's on one side, so subtract 9x from both sides. That's negative x equals 12. To get rid of the negative on the x, we'll go ahead and multiply by a negative 1. Part C, we have 3 and 9. 3 is already basic, so we'll leave it as 3 to the power negative 4x. 9 is 3 squared, so this is 3 to the second power. And then 5 minus 3x is also there. The bases are the same. We can drop the bases. Negative 4x equals 2 times 5 minus 3x. So negative 4x equals 10 minus 6x. Put all the x's on one side, so add 6x to both sides. This is 2x equals 10. Divide by 2. X equals 5. 27 and 81 are both powers of 3, so this is 3 to the third power, and then minus x minus 1 equals 81 is 3 to the fourth power, and then it's also to the power 2x. So 3 minus x minus 1 equals 4 times 2x. Open up the parenthesis, negative 3x minus 3 equals 8x. Put all the x's on one side, minus 3 equals 8x plus 3x, that's 11x. So negative 3 over 11 will be the value for your x. Number 9, we're expanding the logarithm. So we'll go ahead and expand this log with 3 different letters inside of it so that each logarithm has only one letter and there's no exponents. So this is log base 10 of a to the fourth. Instead of the square root of b, I'm going to write it as b to the 1/2 power and then c squared. Since we have 3 letters, we'll have 3 logarithms. This is log base 10 of a to the fourth plus log base 10 of b to the 1/2 minus, since c was in the denominator, log base 10 of c squared. And then the exponents have to go to the front of the log. So this will be 4 log base 10 of a plus 1/2 log base 10 of b minus 2 log base 10 of c. Now we're going to do the opposite. So combine multiple logs into one single logarithm. You're going to start by getting the exponents from the in front of the log back into the exponent form. So this is log base 3 of a to the second power minus log base 3 of b to the fourth power. Oop, that's still a minus. Minus log base 3 of c to the 1/3 power. Okay, now the log that does not have a minus in front of it, that letter will go in the numerator. So a squared is in the numerator, then divided by, since both of the other two logs have a negative sign, their letters will go in the denominator. B to the fourth, and then c to the 1/3. You can also represent 1/3 as a cube root. It will be correct. Change of base formula. So change of base formula looks like this. Log base b of m can be written as log base 10, let's say, of m divided by log base 10 of b. Why base 10? Because it's built into our calculators. So base 10 or base e is what makes sense here. So now our numbers, log base 12 of 3 would be log base 10 of 3 divided by log base 10 of 12. And if you put it into a calculator, that's 0.442. and then a bunch of exponential equations. So let's go ahead and start with the first one. The first one, the exponential function, is already isolated on the left-hand side, so we can go ahead and take a log base 10 of both sides. So this is a log of 11 to the negative 3y power equals log of 8. Now, this power will go to the front of the log negative 3y times log base 10 of 11 equals log base 10 of 8. Now we're going to divide by whatever is attached to the log. So negative 3 and then log base 10 of 11, both sides. Negative 3 times log base 10 of 11. On the left-hand side, all you will have left is y, and on the right-hand side, it's log base 10 of 8 divided by negative 3, log base 10 of 11. Notice we're not putting anything into a calculator until the very end. Now you're ready to put it into a calculator and get the result. Negative 0.29 on this one. If you round the intermediate computations, you will probably end up with a round off calculator error. Part B, we need to isolate the exponential on one side, which means we have to subtract 7 from both sides first. So this is 2 to the power 3 minus y equals 30. So now we have to take log base 10 of both sides. Now the exponent will go to the front of the log 3 minus y in parentheses this time times log base 10 of 2 equals log base 10 of 30. We need to divide by log base 10 of 2, so 3 minus y equals log base 10 of 30 over log base 10 of 2. Now we have to subtract 3 from both sides. So negative y would be log base 10 of 30 divided by log base 10 of 2 minus 3, but that's a negative y and we want a positive y, so multiply everything by negative 1. So that's y equals 3 minus log base 10 of 30 divided by log base 10 of 2, and then put it into a calculator to get the approximation. Negative 1.91. Part C, we have to add 5 to both sides first. So negative 3 to y minus 4 equals negative 8. Then get rid of the negative just by multiplying by negative 1. 2y minus 4 equals 8. Now we can go ahead and take a log base 10 of both sides. Put the power in front of the log, so 2y minus 4 log base 10 of 3 equals log base 10 of 8. Go ahead and divide by log base 10 of 3, so 2y minus 4 equals log base 10 of 8 over log base 10 of 3. Now, we're going to have to add 4 to both sides, so 2y equals log of 8 over log of 3 plus 4. And then the last thing we're going to do is divide by 2. So the whole thing on the right will be divided by 2. So y would be log of 8 divided by log of 3 plus 4, and then the whole thing is divided by 2. Now approximation, 2.95. All right, part D, in order to isolate the exponential, we have to divide by 3. So this is 5 to the 4y equals 10 over 3. Log base 10 on both sides. Again, I'm not putting 10 over 3 into a calculator. I'm keeping it as a fraction to avoid the calculator errors. 4y times log base 10 of 5 equals log of 10 over 3. Divide by everything that's attached to the y. 4 and then a log of 5. 4 log of 5. Y equals log base 10 of 10 over 3 divided by 4 times log base 10 of 5. 0.19. And the last one, the bank offers an investment account with an annual interest rate of 5.75, compounded quarterly. Lisa invests $2,500 into the account for 5 years. So we need to answer the following questions. We're going to be rounding to the nearest cent, so 2 decimal points. So the formula is given on this quiz. So let's go ahead and see what's actually given in the problem. P is the amount you start with, so that's 2,500. We have R, which is 5.75%, but we got to change it into a decimal. Do not truncate any of the numbers, keep all of them. Then we have T is 5, and we have N compounded quarterly. There's 4 quarters in 1 year, so N is 4. So we'll go ahead and put all of that into the formula and figure out what the amount is. A equals 2,500, 1 plus 0.0575 divided by 4 to the power 4 times 5. That is 3,325 and 91 cents. Now, in order to find the interest, we have to take the money that's in the account after 5 years and subtract the original amount that we put in. And that will be $825.91 in interest.